A, C, F, H, and B, D, G, J. They are two identical parallelograms. So let's just draw them up. Okay. Okay. Since we know that it's parallelogram, right? Let's look at what's so interesting about such a property. We all know that this is a rectangle. A parallelogram is exactly the same except that it's being stepped on. So the sides are the same dimensions. However, the angles are no longer the same. When dealing with such a shape, the two key things you have to look at is this. There are two sets of parallel lines. So we need to look for the cement shapes like that, where these two angles will add up to 180 degrees. Or we will need to look for the segment shape, which is like this, where these two angles are the same. Yeah. The third property that you need to look at, and it's probably the last one, is that if you draw a line across it, this bottom angle will be equal to the top angle. And the two opposite angles will be exactly the same. Okay, so with all this being said, let's see what we can do. Well, remember that we said about the last thing I said about opposite angle. So this is definitely 65 because it's opposite to the first 65. And this is BJH. So answer A, 65. The second thing we need to find is DBJ. DBJ is this angle here. Well, remember I said about the cement, the one that's in green. So 180 minus 65 should get 115. And that's the answer for. Now, the last thing that we look for is this angle here. EH. F. So what we're going to do to find this? Well, there's a few ways to do it, but the easiest way I found was this. This is a straight line, so hence this is 80 degrees. Right, this is a straight line, so this is 60 degrees. This bottom here, since the parallelograms are identical, this will be 65. So what's the final answer? It will be 180 minus 80 minus 65. That will give us 35 degrees. So that's all for this question. The next question is an angle question again. This time around, we have the same parallelogram again. So I think this school really likes it. Let me mark it up for us. The next thing they told us is there's an isosceles triangle. Perfect. But do we know which are the two sides that are the same? Well, they did tell us the information. FD equals to FB. So these two are the same, which means we immediately know what are these two angles. So let's find it. So these are all 55 each. I will not mark it because then it will cloud out the picture. Okay, so what do we need to find? We need to find B, D, C. Right. So it's this yellow one. Okay. Taking what we have, we can actually find all the angles within the parallelogram, and that will pretty much solve the question. So let's just find this one here. Big angles on the straight line, right? Actually, there's no need to go so far. Remember, there's one of this condition that I mentioned just now being the segment. where these two angles are the same. So we actually have a segment, and we can do that to solve the question. Let me highlight where we want to find. We want to find this and the corresponding z's here. Okay. And we know that the unknown here is 55. So actually, all we need to do is 180 minus 86 minus 55. That will give us 39. So this is 39. And for segment, this final answer will be 39. Okay, so the answer is 39. So actually, with these two questions combined together, we would have already made use of every single property you will need for understanding how to use a parallelogram. Yeah. Okay, now the next question we're going to is a circle question. Two identical quarter circles. Okay. So the parameter of the shaded figure of A is 140 more than the parameter of unshaded part of A. So let's just map out what this means. The shaded area of A, the shaded parameter of A, lines, right, is 140 more than the unshaded. Okay, unshaded is something like this. I won't draw exactly touching because then it will cloud our vision. Okay, this is the unshaded parameter, the red color. So what exactly is 140 more? Well, actually, this is exactly the same. The curve is exactly the same. So we can erase it out. And then we see another set of exactly the same curve. And since the figure is a square, right, you can just erase off one side of the red and then one side of the red. And this is 140 more. So this is 70. This is bottom is 70. So we're actually done. We know what is the diameter of the circle. Be very careful. Remember, radius is 35 cm. Okay, we'll use 70 cm. Now, how do we find the shaded area in part B? Well, it's simply the circle. Plus 2 boomerangs. Sorry, plus 3 boomerangs. So that's what you need to find. So let's find what is a quarter circle. Well, a quarter circle is basically 35 times 35 times pi. That's for the full circle. And then times 0.25 for the quarter circle. So 35 times 35. You should get 962.5. This is for a quarter circle. So let me just draw it. This is for the quarter circle. Yeah. Now, how to find the boomerang? The boomerang is simply take the square, slightly darker, take the square, minus the quarter circle, and that will give us the boomerang. Okay. So we need to find the square first, right? Square is just 35 times 35. One, two, 5. So 1, 2, 2, 5. Need to minus the quarter circle to get the boomerang, right? That will give me 62.5. This is one boomerang. So what's a boomerang? Again, the boomerang is the quarter circle in the square, but we do not want the quarter. We want the other side of it. Okay, so this is one boomerang. So to find the final answer, we will need 962.5 plus 3 boomerangs. So if you press your calculator with these values here. My answer would be 1750 cm squared.